Okay, guys, so today we're going to be going over the law of sines and cosines. I want you guys to consider, what do we already know? Previously in this chapter, we've already solved triangles, and what we've mainly focused on is solving right triangles, right? And the method we used to solve that was mainly using SOHCAHTOA in order to do so. However, the vast majority of triangles aren't right. So what if the triangle isn't right? What do we do? These triangles that aren't right, we actually call oblique triangles. And the remainder of this chapter, and actually the end of this chapter, is going to be taking those triangles into consideration and how we solve them. When we're solving for oblique triangles, there's two methods that we can use. We can either use the law of sines or the law of cosines. So, what information is needed when we want to solve for these triangles? When we can determine a triangle by having at least 3 of the 6 parts known. The 6 parts that we're referring to are the 3 interior angles that make up the triangle and the 3 corresponding sides that make up the triangle. The only stipulation, however, is that at least one of these parts known must be a side length. So take the time and consider why we have this stipulation. Below is an example that kind of shows why this doesn't work if we don't have at least one side length. If I have a triangle ABC here with the respected interior angles, I can create what's called a similar triangle that you guys have worked with in the past that has the same exact interior side lengths. However, the same exact interior angle measures. However, as we can see, the side lengths are very different. So when we only have 3 known angles for a triangle, we cannot solve for a unique triangle. So we're going to focus first on the law of sines. When it comes to the law of sines, there exist 2 cases when we would use this. When we know one angle and 2 sides, and this is a notation for writing it, we can either have the angle side angle or the side angle angle. The method for this is all the same. Or when we know 2 sides and the angle opposite of one of those sides. This is the SSA method. And this is actually a very special case that we're going to focus on. It's called the ambiguous case. And I want you guys to remember this because it's going to take a little bit of a further investigation when we're solving. And one way that you can remember when you're going to have to consider this is, if I was to kind of re-scramble these letters, you guys could probably think of a spelling or an acronym that would maybe help you remember when this is going to happen. But right here is the formula that we're going to use. I encourage you to write this down as we're going to use some examples here to use the law of sines. And I realize you guys can't copy and paste this link as it is on YouTube, but I really encourage you guys to either type in this link or just simply YouTube a law of sines proof. This is a very straightforward proof that will really give you guys some intuition as to how we derive this. So we're going to just start right away with an example. I want you guys to find side length B. So when we consider our triangle here, it appears that we're given an angle, side, angle. So we're going to have to use that first method discussed when solving this. Whenever you guys are given 2 angles for a triangle, which right away, I encourage you guys always for all of these problems to just draw a sketch and start putting in what you know. So when we see that we know 2 angles for a triangle, what do we remember from previous geometry classes? That the interior measure of all angles is 180 degrees, right? So we know 2 of the 3, and we know that all 3 have to add up to 180. So therefore, we could find angle C as well. Angle C is going to be 180 minus 75 plus 60 degrees, which gives us angle C equals 45 degrees. Now we have a setup where we can use our law of sines. We know angle B, we know angle C, and we know the corresponding side for C. So sine of B over B, little b, equals the sine of big C over C. Should be a little c here, but and we just start plugging in the information. So we have the sine of 60 over b equals the sine of 45 over 340. And we'll do cross multiplication here. We'll get b times sine 45 equals 340 times sine 60. And now we'll divide by sine of 45. And this right here will give us side length b equals 416.41. That's our answer for B. So now I want you guys to consider that second case. That was the SSA method. This is the ambiguous case. When we know two sides and the angle opposite of one of those sides, this is when we're going to have a possibility of 1, 2, or no solutions. These figures right here show you guys kind of a little bit of a visual idea of why this is and what this would look like. Figure 2 is when there exists one solution, and I just want to make note that this figure appears to be a right triangle, or they make it look that way, but that's not always going to be the case. It's just going to be a unique solution to the triangle. Figure 1, if we look, this is when there's two possible solutions, and what will end up happening is we'll have, when we solve for our triangle ABC, we'll get a side length here, A, and we'll be focusing on this interior angle. But I want you to pretend as if A was on a hinge here. And if we were to swing it over, we have to consider this possible angle for angle B as well. And then when there's no solution, what this would mainly look like is that this little A here wouldn't reach down, and it would be too short to finish the triangle.